Dear students, the next chapter we are going to start is liquid state. So you know what is the liquid and what is solid and what is gases, and also you know some properties of liquids. So the same properties, there are some properties which we are going to study in this topic are the surface tension, viscosity, refractive index of the liquid, and the liquid crystal. So by use of these properties we can determine the structure, the composition of the liquid mixture. So see here the importance of physical measurements like surface tension, viscosity, refractivity of liquid has considerably increased because of their usefulness in elucidating composition and structure of the molecule. Means what? To study or to know the structure of molecule, we must know its physical properties. So nowadays there are many instruments like spectroscopic methods. These are available for the determination of structures. Still, we study the different properties of these liquid structures. So the physical properties are based upon the measurement of additive and consecutive properties of these liquids. So let's begin with what is meant by additive and what is meant by constitutive properties. So now see here, an additive property of a molecule is defined as one which is the sum of the corresponding properties of the constituent atoms. Means what? Now see here. So this property, that is additive property of a liquid, is nothing but it is the sum of corresponding properties of the constituent atoms. So this property is the sum of the corresponding properties of the constituent atoms present in that liquid. Thus the mass or the weight of an atom does not alter, and the molecular weight of substance can be found out by adding up the atomic weight of various atoms present in the molecule. If you are going to calculate the molecular weight of any liquid or molecular weight of any compound, we must add the atomic weights of various atoms which are present in that molecule. So what we have did here, we are adding the atomic weights of each and every atoms in that molecule. So therefore it is known as an additive. Similarly, the molecular heat of compound is the sum of the atomic heats of the atoms present in it. So these are the two examples of this additive properties. One is mass and another is the molecular heat of compound. So the next property is a constitutive property of a molecule. Now see here what it means. A constitutive property of a molecule may be defined as the property which depends upon the constitution of the molecule. Constitution of the molecule, that means the arrangement of atoms within the molecule. How the atoms in a molecule are get arranged with each other. So that arrangement of that atom decides the constitutive property of the molecule. So they have given an example here. So optical activity. So this term will be studied in stereochemistry. I think in 12th standard you have heard about this word, optical activity. So this is a property of a compound or liquid. It is because of the presence of asymmetric carbon atoms in a molecule. Means the carbon atom which is present in the molecule must be bonded with 4 different atoms. So now see here, if the carbon is there, so it must be bonded with 4 different atoms. So in that case, this carbon is considered as a asymmetric carbon atom. Means the molecule which contains this asymmetric carbon atom, it shows optical property. Means what? The arrangement of atoms. So the arrangement of atoms in the molecule decides the property, and therefore this property is known as constitutive property, that because of the presence of arrangement of atoms in that molecule. So this optical activity is a property is only due to presence of asymmetric carbon atoms in the molecule. This property is purely a constitutive property. There are some properties like, see here, the viscosity is there, refractivity is there. These properties are partially additive and partially constitutive. So begin with the study of different properties of the liquid. We must know what is meant by additive and what is meant by constitutive property. So additive property is nothing but it is the sum of the corresponding properties of the constituent atoms, and constitutive property is nothing but it is depends upon the arrangement of atoms within the molecule. So let's begin with the property that is surface tension of the liquid. Now see here what is a surface tension. So you know that when we add a drop or when we throw a liquid on a glass or on a marble, the liquid attains a spherical shape. Okay, whenever you observe that liquid is always in a spherical shape. Okay, and also when we add water to the plant, the water goes into the top of that plant. It is only because of this property, that is surface tension. So flow of liquid on a paper is also because of this property, that is a surface tension. So now see here what is the surface tension. A molecule in the interior of liquid, that is a molecule in the interior of liquid is completely surrounded by other molecules. Hence, on an average, it is attracted equally in all directions. If you see this one, I will draw here. Suppose a beaker is there. So in that beaker, the liquid which is present in the inner is completely surrounded by other molecules. Suppose this is a water molecule, this is a water molecule. So this water molecule is surrounded by other molecules. Therefore, this water molecule is completely surrounded by other water molecules present in that beaker. And this water molecule is equally attracted in all directions because of the presence of water molecules present in that beaker. However, now see here, if suppose the water molecule is present at the top of that beaker or the upper layer of that beaker, then in that case this water molecule is not surrounded with the water molecules in all directions, because now see here, this water molecule is on the upper surface of that water layer and there are different water layers in the liquid interior, but there is no any water layer in the outside. Therefore, this liquid drop on the upper surface is has greater inward pull in the beaker. So this liquid which is on the upper surface has greater pull inward because of the presence of greater number of water molecules in the beaker. So because of this inward pull, now see here, because of this inward pull, the liquid drop has now a tension. So that pressure or that tension is known as a surface tension of the liquid. So the surface tension is generated is because of the liquid droplets on the upper end on the inside of that liquid area. So because of this inward pull of that liquid, the surface of liquid tends to contract to the smallest possible area and behaves as if it were in a state of tension. So now see this diagram here. So in this diagram, these water molecules are in interior, but these four water molecules are at the upper layer of that liquid. So this water liquid drop, this liquid drop has equal pull on all side. This also has equal pull on all side. But the liquid drops which are present on the upper surface of the layer, these liquid drops have somewhat greater pull because of the presence of more number of liquid drops in the interior, but there is no any liquid drop in the upper surface area. Therefore, these liquids have now a pressure, or a surface of liquid tends to contract to the smallest possible area and behaves that these drops are in a tension. So this explanation tells us why a small amount of liquid, that is mercury is there, or a raindrop always take a spherical shape. So this is because the sphere has the least surface area. So this sphere has a least surface area, and because of that always the liquid drops are in a spherical shape. The tension produced on the surface which is pulled to the side of liquid is called as surface tension. Now see here what is meant by surface tension. So the surface tension is produced on the surface which is pulled to the side of liquid, is called as surface tension. Therefore, surface tension may be defined as, now see the definition of the surface tension. So it is defined as the force in Newton acting along the surface of liquid at right angles to any line of 1 meter in length. So the force, suppose this arrow is a force, is in Newton acting along the surface of liquid at right angles. Now see, this is right angles. So that force is created right angles to the surface of that liquid, and this force is known as a surface tension. And this SI unit of the surface tension is expressed in Newton per meter. So you must know the unit of surface tension is Newton per meter. So this force is acting along the surface of liquid with right angles to any line of 1 meter in length. So this is what the explanation of surface tension. So surface tension is nothing but it is the tension produced on the surface of liquid due to the inward pull by the other liquid molecules present in the beaker. So I think you have got this point. So now let's begin with how to determine the surface tension of any liquid. So there is one instrument that is known as a stalagmometer. So this is an instrument. This stalagmometer is used to determine the surface tension of the liquid. So I will explain how the surface tension is determined by use of this instrument. So this method is known as drop number method. So determination of surface tension by use of stalagmometer, the method which is used for the determination is known as a drop number method. Let's see here. The surface tension of liquid can be determined by using an instrument called drop stalagmometer. So in this method, now see here what we going to do here. The number of drops from a fixed volume of liquid between mark A and mark B. So how many number of drops are formed between this area, that number, on the basis of that number we can determine the surface tension of the liquid. Therefore that method is known as a drop number method. Now see here, if suppose this is the instrument where the liquid is sucked in between this mark A and mark B. So this much amount of volume is there in that instrument. So when we open this screw lamp, then the liquid goes outside, and we are going to calculate, or we can going to determine count how many number of drops are there when the liquid flows from A mark to mark B. So by use of that number we can determine the surface tension of that liquid. Now see this instrument, the lower portion, so this is the lower portion. So the lower portion of this stalagmometer, it consists of this fine capillary tube through which the liquid is flowing from upper portion to the lower. So to this lower portion, so these two lower portion, the rubber tubing Y-shaped glass is attached to that lower portion of this stalagmometer. So this whole portion is connected with a Y-shaped glass tubing. Now see here, when we are going to start the experiment in a lab, so this is the practical in your lab. So I will explain here, then you will get the idea how to determine the drop number method or how to determine the surface tension of the liquid. So this is the screw clamp, this is the pinch cock, this is the rubber tubing, and this small area is a capillary, and this mark is A to B where the liquid is taken in between that area. Now see here, so initially the screw clamp is closed, so we will close this one. After closing this screw clamp, the liquid is sucked into the stalagmometer to a level mark A, above the level mark A, by opening this pinch cock. Means what we did here, initially the screw clamp is closed and the liquid is sucked from below up to this more than the liquid is sucked above the mark A through this pinch cock. So now then next, this pinch cock is closed then, okay, then after closing this pinch cock, now we are going to slowly open the screw clamp so that the liquid which is coming outside that capillary has a number between 15 to 20 per minute. It means the number of drops coming outside the capillary in 1 minute should be maintained between 50 numbers to 20 numbers. Once, now see here, once this drop number is get maintained, then we are going to close the screw clamp now, and again the liquid whose surface tension is going to be determined is sucked in this capillary or in this instrument by opening the pinch cock. So the liquid is sucked above the mark A, suppose up to here, the liquid is sucked here up to this mark, above the mark A, and finally the pinch cock is closed, and now we are the pinch cock is closed, and when the pinch cock is closed and after closed, then liquid is coming outside the capillary because of the gravitation, and we already maintained the 15 to 20 drops per minute by maintaining the screw clamp. So we are calculating the time required, how many in 1 minute, how many number of drops are coming for that liquid 1 is counted, and the same procedure is carried for the for more number of liquids, suppose liquid 1, liquid 2, liquid 3, and we are calculating the time required to flow the liquid from mark A to mark B. So if suppose the liquid is coming, suppose liquid 1 is there and the liquid 1 is coming from the capillary from the mark A to B, so the number of counts are, suppose n1 number of drops are coming in 1 minute, then if 2 pi r y1 cos theta, 2 pi r y1 cos theta, if it is the force due to the surface tension on a single drop, suppose this is the force which is on the single drop, then if suppose n1 number of drops are coming outside that capillary, then the force on that whole liquid drops are 2 pi r y1 n1. So this n1 is nothing but the number of drops for that liquid, number of drops for that liquid. So 2 pi r y1 n1 cos theta is the surface tension, or it is the force on that liquid drop. So now see here. So in the next we are going to explain, we are going to derive the equation required for, or equation to calculate how to calculate the surface tension by use of this drop number method. So just I explained you, suppose the 2 pi r y1 cos theta is the force due to surface tension on a single drop. Then suppose there are n1 number of drops are coming outside that liquid, then in that case the force on that total number of liquid drops are 2 pi r y1 n1 is the number of drops cos theta. So this is the surface tension on the or force due to surface tension on the liquid. So this force will be balanced by the weight of n1 drops, which is m1g. So in the capillary, the force which is generated, or the force due to surface tension on the liquid, has to be balanced, and that the force is balanced by the weight of n1 drops, and this weight is m1g, where m1 is the mass and n1 is the drops of that liquid. So now, so this force is balanced because of the weight of that liquid drops. So this is a 2 pi r n1 y1 cos theta is equal to m1g. So this force is balanced by the mass of that liquid drops. So we know that density is equal to mass upon volume. So this equation we know, density is equal to mass upon volume. So mass is equal to density into volume. So d into v is nothing but the mass. So we will put this values of mass into, or the volume and density into this equation. So this mass becomes v into d1, that is density of that liquid and volume of that liquid. So this is the equation number, suppose 1, equation number 1. So 2 pi r n1 y1 cos theta is equal to v into d1g. So v into d1 is nothing but the volume of liquid between mark A and B, and d is nothing but the density of that liquid. So now we have just calculated the number of drops required for the liquid 1. So the same procedure is carried for the or more number of liquids. So before carrying the experiment for different liquid, so we must clean and dry that stalagmometer by use of acetone or alcohol. So the same procedure is repeated for another liquid, and then another liquid, and the number of drops are obtained by that liquid is suppose n2. So n2 number of drops are coming outside that capillary in a minute, in a single minute. So the equation for that liquid is written as 2 pi r n2 y2 cos theta is equal to m2g. So this is the force, that is 2 pi r n2 y2 cos theta, which is balanced by the mass of liquid, that is m2g. So the mass is converted here, we know that is, so volume into density is equal to mass. So we are going to put the value of mass into this equation, and the equation becomes 2 pi r n2 y2 cos theta is equal to v d2g. So this is the equation number 2, this is the equation number 1. So we are dividing equation 1 and equation 2. Then 2 pi r1 n1 y1 cos theta divided by 2 pi r2 n2 y2 cos theta is equal to phi into d1g phi into d2g. So all these values are same. 2 pi r1 is same, 2 pi r2 is the radius of that capillary is same, so it is get cancelled. Cos theta is get cancelled. G and G is also get cancelled here. The volume is same for these two liquids. Then the equation becomes n1 y1, I will write initially n1 y1 divided by n2 y2 is equal to d1 d2, and this equation is written in terms of this type, that is n1 n2 is equal to d1 d2 multiplied by y2 upon y1. So in the book you should make a small correction here, so you should write y2 upon y1 instead of y1 upon y2. Then y2 is equal to, now so y2 is equal to n1 upon n2 multiplied by, now d2 comes upper side, so d2 by d1, and this y1 comes on the left hand side, therefore y1 is equal into n1 n2 d2 d1 is equal to y2. So this equation is correct here. So by use of these equations we can calculate the surface tension of the liquid. So hence, if you know by calculating the number of drops for liquid 1, that is n1, and for the liquid 2 n2, and if you know the densities of liquid and the surface tension of any one of the liquid, then we can calculate the surface tension of another liquid by use of this equation. So this is the equation by use of which we can calculate the number of the surface tension of the liquid. So y2 is equal to n1 upon n2 into d2 upon d1 into y1. By use of this equation we can calculate the surface tension of the liquid. Okay, so there are different liquids are there in a table, and now see in front of that the surface tension is given at 293 Kelvin. So for the water the surface tension is near about 72.75, which is into 10 raised to minus 3 Newton per meter. So for different liquids different surface tensions are calculated. Now one example I will ask here, or one problem we will solve here now. If suppose the question will be asked in the exam, suppose at 293 Kelvin water form 29 drops, that is water forms 29 drops when flowing through the capillary of stalagmometer. Suppose we are calculating the number of drops at 293 Kelvin for water, and it counts 29 drops. While suppose a equal volume of ether, so equal volume of ether is also taken for calculating the number of drops for that liquid, and suppose it gives us 86 drops to come outside that capillary from mark A to mark B. Then if suppose the density of water molecule, density of that water molecule is 0.997 and the density of ether is 0.70 gram per centimeter cube. So this is the density of these two liquids. For water it is 0.997 and for ether it is 0.70. Now they have asked us that find the surface tension of ether. We are going to calculate the surface tension of ether molecule. Calculate the surface tension of ether. If the surface tension of water molecule is, suppose the surface tension of water molecule is 72.8 into 10 raised to minus 3 Newton per meter. Okay, so all these, this is a given. The problem is now see here at 293 Kelvin the water gives 29 drops when it is coming from the stalagmometer from mark A to mark B, having the density is 0.997, and the same procedure is followed for the ether molecule, and this ether liquid gives 86 number of drops when it is coming from the capillary from mark A to B, having the density 0.70. The surface tension of liquid is also given, it is 72.8 into 10 raised to minus 3 Newton per meter. And the question is calculate the surface tension of ether liquid. So we will consider here, that is, we know the equation, that is 2 pi r1 y1 2 pi r1 y1 n1 cos theta is equal to m1g, and it is also written in terms of phi into d, that is phi into d1g. This is for a water molecule. Suppose for ether molecule it is 2 pi r2 y2 n2 cos theta is equal to phi into d2 into g. Okay, we know this equation, that is n1 upon n2 is equal to d1 upon d2 into y2 upon y1. So you can write this equation directly, or we so this y2 is nothing but the surface tension for the ether molecule, and y1 is nothing but the surface tension for the water molecule. So the question is, we have to calculate the y2. Therefore y2 is equal to, so n1 upon n2 is as it is, so d2 comes here, so d2 divided by d1, and the y1 is in the denominator, it comes on the numerator in the left hand side. So now we know that is number of drops for water molecule, it is 29. We know this is 29 water drops, and 86 is for ether molecule. Density of water is density of d2, that is density of ether liquid is 0.70, and that of water molecule is 0.997, and the surface tension of the water molecule is 72.8 into 10 raised to minus 3. So by calculating or by solving this problem, we have this answer 17.24 into 10 raised to minus 3 Newton per meter. So this is the surface tension for the ether. For ether molecule, the surface tension is calculated by use of this equation, that is y2 n1 upon n2 d2 upon d1 into y1. So these are the simple examples. It will be asked in the examination also. So initially you must know what is given in the problem and what they have asked to calculate, and what is the formula for the calculation of that problem. So by putting all these values, you can easily calculate, or you can easily solve the problems from that point. So in today's lecture, we have seen what is meant by a liquid state, what is liquid, and what are the properties, additive properties and consecutive properties, what is meant by surface tension, what is its unit, that is Newton per meter, and how to determine the surface tension of liquid, and the method is the drop number method for the determination of surface tension. And after that we have just solved the problem, that is derivation of this equation to calculate the surface tension, and we have seen the problem also. So if you go through this simple point, you will come to know how to determine the surface tension of different liquids by use of the equation, that is y2 is equal to n1 upon n2 into d1 upon d2 into y1. So in the next chapter we will start, so in the next point we will start viscosity.